Hey guys, welcome. Thank you for joining this session. And we're going to spend the next roughly 15 minutes talking about Karpenter and its great features that will actually help you achieve cost efficiency and make your setup really adaptive at scale. So before we start, I would actually want to ask you a quick question. How much of you guys are using Karpenter today in production? Perfect, amazing. And keep your hands up, those who use it for managing spot instances. Amazing, perfect. Thank you for sharing. So my name is Alexei. I'm a co-founder and CTO at Zesty, where we are focusing on making cloud really efficient. And I hope you will actually be able to take some actual and practical tips from this presentation that you can implement this in your setup. Let's dive in. So when actually it comes to stability and performance, it's really easy to solve the problem by just throwing money at the problem, right? We can always take the biggest, the most powerful instances out there and just get an amazing performance at a terrible cost. On the other hand, if we squeeze the budget and we scale down to the bare minimum, and suddenly efficient becomes unavailable. So as DevOps engineers and platform engineers, our goal is to find the sweet spot. Our goal is to run complex production workloads that are demanding for resources, give them just the right infrastructure, and it shouldn't be over-provisioned or under-provisioned, and this is a tough balance to strike, right? And especially in Kubernetes, it always means tuning the configuration to stay efficient, and it's easier said than done. So let's dive in. Basically, one of the best features in Karpenter, it's very powerful, called consolidation policies. What it actually does, it takes and monitors your nodes and looking for underutilized nodes, and actually checking if it can safely terminate them to save costs and move the containers somewhere else. Now, while this sounds appealing and sounds great, there are some guardrails and fine-tunings to this behavior you want to have in your setup. Number one is using what's called PDB, or pod disruption budgets. It actually controls and making sure that not all of your replicas are being consolidated at the same time. You want to make sure that you control how much replicas Karpenter can interrupt at any given moment to keep your setup safe, right? Another thing is consolidation delays. You can always configure how long Karpenter will wait until it actually goes and terminate nodes. And you're setting this in order to prevent Karpenter from doing this during short-term dips in usage. So it's not gonna go crazy and interrupt your containers. So by actually implementing those controls, you can avoid consolidation during your peak traffic hours, and you can see an example configuration here to set this up. Okay, another important strategy is to choose the right instances for your pool. So it's not just about what's available. It's about giving the Karpenter the right amount of flexibility and give him a set of broader choice. So you definitely want to have diversification, because Karpenter actually balances between cost and availability and trying to find the instance that delivers the best performance at lowest cost. So in theory, the more instant types and sizes you give Karpenter across different families, generations, and sizes, so in theory, it can find a better fit. But you always wanna avoid extremes, right? You don't want to include instances that are too small, because small instances are causing a lot of network overhead. They actually adding more complexity to scheduling and monitoring. So in this example, we are actually cutting out all the tiny flavors, for example. But also, you don't want to have too large nodes because we spoke about consolidation earlier, and basically large nodes that are not fully utilized is a waste of time, is a waste of money, right? And making the consolidation less efficient. So to summarize, basically all we want to do is constantly monitor the behavior of our cluster, and it's up to us to define what's too small or too big in our exact case. Another factor that is constantly overlooked is daemon sets. Basically, those are containers that are running for system services like monitoring, logging, and telemetry, and all of the system stuff, and running per each node. So when we have larger nodes, we have small overhead of daemon sets. And on the opposite, if we have a lot of small nodes, it means we have a large overhead of daemon sets, and actually this is consuming resources. And especially if we're using any software that is licensed per node, this can actually silently inflate your costs. So take this also as a consideration. So let's be honest, talking about cost savings without mentioning spot instances probably is not the right thing. And the good news is that Karpenter makes management of spot instances really easy. You just need to allow spot instances in your node pool, and Karpenter will just take it further. It will automatically identify spots with best price and availability, take this into account and choose the right machines, and also take care if they're interrupted, so pods can move somewhere else and basically provide cost savings. While this sounds good, so let's think where this can fit, right? Where we can use spot instances. And if you ask me, I think everywhere. Every workload that can tolerate for interrupts, whether it's a web server behind load balancer, whether it's a stateless microservice, batch jobs, your dev, your staging environments, all of them can recover quickly from spot interruptions, and you can leverage this for cost savings. So the best practice here is actually to configure spot instances with a failover to on-demand, and you can see an example configuration here. This actually Karpenter in this case will actually try to provision a spot instance for cost savings, and if there is no capacity, will transparently move you to on-demand. So it's a good idea to create two separate node pools for spots and on-demand. So you can actually use node affinity in your deployments to configure how much you put to spot and how much you keep on demand for safety. And finally, you always need to keep an eye on fallbacks. If you have too much fallbacks and you're falling to on-demand frequently, and we spoke about choosing the right instances, maybe in this case you want to give Karpenter much broader selection, because you can use instances that maybe not the perfect fit, but still providing more than 60% discount, so it's the right thing to do. Another strategy would be using Graviton instances. As you probably know, Graviton provides at least the same performance or even better for a lower price. And most of the modern applications are able to run on ARM architectures with no code change. The only investment you have here is to make sure that during your CI process, you're building your Dockers both for ARM and x86, and you have both versions of the container in your registry, and Kubernetes will automatically pick the right one, depends on the node that this workload is running. Another thing is, actually, it's a last tip for today, and please use this with caution, not for production, but it can really save some costs. As you probably know, cross-availability zone traffic is very expensive. So for non-production environment, what you can do is actually you can limit your node pool to a specific AZ. And it basically means that you can enforce data locality at the infrastructure level. So it's actually going to reduce significantly the cost of networking. But again, it's not something you can do in production. I don't recommend putting this stuff in production. But as you can see here in this example, we can also configure a failover, basically use weights and affinity rules to make sure if there is a failure of a zone, we can actually go and utilize another one. Okay? So when we spoke about all of these best practices, and the big question comes up, are we done? And the answer is not really. Basically, there is still a lot of challenges to solve, and let's mention them. Kubernetes gives us a lot of metrics, and it's really hard to connect them down to costs in order to identify inefficiencies. So especially when we operate large environments with multiple clusters. So we talked about Karpenter a lot, and even if Karpenter makes instant decisions and it's working pretty amazing, it doesn't mean that the underlying infrastructure can keep up, because it takes a lot of time. It's about a couple of minutes for the infrastructure to be ready to serve our containers. And obviously, there are still operational complexity to make sure we constantly modify and adjust our setup to make it truly efficient. So basically, the question is, can you afford your teams to be constantly invested into making sure your environment is configured properly? And at the end of the day, in large environments, we actually need a continuous automation, something that will provide us the ability to be focused on building rather than optimizing. And this is exactly where tools and platforms actually come to assist. So at Zesty, we develop a Kubernetes optimization platform that helps closing those gaps. Our platform makes actually provides you with a deep visibility into all of your clusters and containers, both from usage and utilization perspective, and making it very easy to identify inefficiencies. It uses predictive models to make scaling decisions far more efficient. We execute optimization actions automatically on your behalf, so again, your teams can focus on building and not optimizing. So our platform automatically resizes workloads, both vertically and horizontally, based on workloads behavior. It covers not just CPU and memory, but also persistent volumes for stateful workloads that are requiring a local storage. Zesty automatically distributes, and by the way, we're calling this a resource optimization layer that actually goes and do an active right sizing. And also, we are navigating and distributing workloads between spot instances and saving plans to reduce the expensive on-demand costs. With our fast scale technology, basically we maintain a fleet of hibernated nodes that are pre-cached and have all of your containers and stuff ready to kick in 30 seconds. And basically this allows us an instant recovery from spot instance failures. So you can move more workloads to utilize spots without the risk of being interrupted or having no capacity. So we call it a financial optimization layer. And basically Zesty is the only platform out there that combines both resource optimization and cloud financial optimization practices to provide at least 70% cost savings for your clusters. And if you guys want to learn more and hear exactly how we can help companies achieve efficiency, our booth is actually located right here to my right. So feel free to come say hi and ask questions. Thank you so much and have a good conversation, good convention ahead. Thank you.